In the previous two demos, we discussed how to introduce explicit errors in the application. The main benefit of this approach is, as you might have guessed, its explicitness. You can clearly see which errors the application generates and in which circumstances they might happen. Our errors have two fields, the error code and the error message. The clients should bind to the error code only. It is part of the contract between your API and its consumers. Once published, you shouldn't modify those error codes. Otherwise, you will break backward compatibility. Error messages, on the other hand, are just for debugging purposes. They help developers identify the source of the issues. Ideally, the consumers of the API shouldn't show these error messages to the end users and should come up with their own error messages. But for simpler applications, showing these messages to users directly works too. The fact that only the error code is part of the contract with the clients is reflected in this method. It shows that only the code property participates in a quality comparison between errors, which means that two errors with the same code but different messages will be treated as the same error. All error codes should be unique. You need to write a unit test that will enumerate all errors and make sure that their codes do not repeat. Along with the error code and error message, you may also introduce a field for the HTTP code. This is to enable mapping of different errors to different HTTP response codes. Note that technically this is a violation of domain model purity, because the error class is part of the domain layer, and it shouldn't deal with application concerns. But this is a minor concession, because the HTTP code itself is not an out-of-process dependency, and it's easy to manage because of that. Another dent in domain model purity is that we are combining all errors in one list, including errors that don't belong to the domain layer, such as internal server error. Technically, those should be separated into domain and non-domain errors. But I personally find that it's more useful to keep the full list of errors in one place, rather than to maintain perfect separation. We have also standardized the API output. All our responses now follow the same structure, which makes those responses easier to consume. Successful responses return a result, while failed responses the error details. For that, we've introduced an envelope class. Note that our envelope currently shows only one error, but we can easily show multiple errors. For that, we just need to modify the envelope class to include a collection of errors, and modify our model state factory to fetch not just the first error in the model state, but all of them. And of course, you can always come up with your own envelope structure and include the fields that are useful in your particular project. Let's now switch gears to more complex validations and talk about the check for student email uniqueness. We've already discussed the topic of error codes, so I'm removing this comment. We also talked about how to return a list of errors instead of just one error. For that, we need to query not just the first error from the model state, but all errors and record them into the envelope. Of course, we would also need to change the envelope structure to include a list of errors instead of just one. So I'm removing this line too. We'll discuss this one shortly, but first let's quickly address the check for the request non-emptiness. We already have this check. ASP.NET started to do this validation for us after we added this API controller attribute. There is one issue with this check though. Let's see that issue in practice. We can simulate the null request body by removing the JSON payload entirely, sending it, and you can see that our deserializer has thrown an exception because the error ASP.NET generates doesn't follow our error pattern. This message is generated automatically, and there is no way for us to change it, but we can add a quick check for that message and transform it into one of our explicit errors. Let's run the application again, sending the same request, and you can see that now the API doesn't fail and returns the proper error. It even correctly indicates the invalid field, which is empty, because the issue is with the JSON document itself, not one of its attributes. Alright, having that out of the way, let's remove this line and discuss the email uniqueness validation. So how can we implement it? One way would be to make the controller check for any existing students with the same email before instantiating the new student. We can do this by introducing a new method in the student repository that would search the student by their email and use that method in the controller, like this. If the existing student is not null, then return the email is taken error. This error currently requires the email address as an argument. Let me remove it for brevity. Good. So this is a perfectly valid way of doing the check, but this approach has an issue. The issue with this approach is that it fragments domain logic and thus violates the second and the first guidelines of the proper validation technique. This validation rule now doesn't belong to the domain layer. It is controlled by the application layer instead. And as you might remember from previous modules, the second guideline tells us that all validation rules should belong to the domain layer, no matter how simple or complex they are. This code also violates the first guideline, the always valid domain model. It is now possible to change the student email without checking for its uniqueness first. The student entity doesn't protect itself from this invariant violation. In other words, our domain model is not fully encapsulated. We can fix this issue by moving the responsibility to verify the email uniqueness inside the student class, like this. This version gets rid of domain model fragmentation and restores full encapsulation. Our domain model is now guaranteed to be always valid. But this version achieves that at the expense of another important property, domain model purity. A pure domain model is a model that doesn't reach out to out-of-process dependencies, such as the database. To be pure, domain classes should only depend on primitive types or other domain classes. At this point, you might ask, what if we replace the concrete student repository class with an interface, like iStudentRepository? Wouldn't that introduce an abstraction on top of the database repository and therefore help us decouple the domain layer from the direct reference to the database? No, it wouldn't. The dependency on the iStudentRepository interface is an explicit reference to the database. It is no different from the concrete student repository class. That's because the only reason for introducing this interface is to enable access to the database. Think of it this way. To see how pure your domain model is, you need to imagine how you would design it if you didn't have to persist any data to the database, and all you had to do is keep that data in the application memory. Then you need to compare this design to what you ended up with in your project. The difference would be the dent in domain model purity. And the difference here is the iStudentRepository interface. The domain class simply wouldn't need to work with this interface in a setting with no database. You don't need a repository for an object that is already in the memory. Therefore, this interface is an explicit reference to the database. The same is true for other techniques, such as passing in a delegate that would check for email uniqueness. Alright, so how to preserve both the domain model purity and domain model encapsulation? This is where the DDD trilemma comes into play. So what is the domain-driven design trilemma? The DDD trilemma states that you will not be able to have the following three properties all at once: domain model purity, domain model encapsulation, also known as completeness, and application performance. You will only be able to have two out of these three properties. Domain model encapsulation is when the domain layer is able to fully protect itself from becoming invalid. Such encapsulation may only be achieved when all the application's validation rules are located in the domain layer. Domain model purity is when the domain layer doesn't have out-of-process dependencies. Application performance is defined by the presence of unnecessary calls to out-of-process dependencies. The performance is involved in this trilemma because in theory you can achieve both domain model encapsulation and purity by loading all existing students into memory and passing them to the student class as an argument. This version's domain model is pure. The student now only depends on other students. It is also encapsulated. All the validations are located in the domain layer. But of course, it's not practical from the performance standpoint, because we have to query all existing students on each registration. This choice of encapsulation and purity at the expense of performance is located here on the diagram. I called it pushing all external reads and writes to the edges of a business operation. The second option here is to inject out-of-process dependencies into the domain layer. This option keeps performance and domain model encapsulation, but it does it at the expense of domain model purity. This is the second option I showed in the previous clip, when I injected the repository or the repository interface directly into the student class. Finally, the third option here is to split the decision-making process between the domain layer and controllers. This option helps with both performance and domain model purity, but it concedes encapsulation. With this approach, you need to introduce decision-making points or business logic in the controller. This is what we did initially when we put the email uniqueness check in the controller method. Note that the first approach, pushing external reads and writes to the edges of a business operation, is sometimes acceptable. It works best when a business operation doesn't need too much data from the database and naturally follows the read, decide, act structure, where it has three distinct stages: retrieving data from the storage, executing business logic, and persisting data back to the storage. There are a lot of situations where these stages are not as clear-cut though. In the email uniqueness scenario, for example, we would have to query too much data to preserve domain model encapsulation. In other scenarios, we might need to query additional data from an out-of-process dependency based on an intermediate result of the decision-making process. Writing to the out-of-process dependency may also depend on that result. So, which approach to choose? If you can concede performance, then you should definitely choose the first approach. This will give you both encapsulation and purity. If performance degradation is too large or simply not something you can give up, then the decision comes down to the choice between domain model encapsulation and purity, injecting out-of-process dependencies into the domain layer or splitting the decision-making process between the domain layer and controllers. Which one is better? I strongly recommend that you choose domain model purity over domain model encapsulation and go with the third approach, splitting the decision-making process between the domain layer and controllers. I know that contradicts the first and the second guidelines of validation, which are always valid domain model and keeping all validation rules in the domain layer. But in my experience, domain logic fragmentation is a lesser evil than merging the responsibilities of domain modeling and communication with out-of-process dependencies. Domain logic is the most important part in the application. It's also the most complex part of it. Mixing it with additional responsibility of talking to out-of-process dependencies makes that logic's complexity grow even bigger. Avoid this as much as possible. The domain layer should be exempted from all responsibilities other than the domain logic itself. I mentioned earlier that we would have to make concessions and that we will not be able to follow the three guidelines of validation all the time. The first concession was about simple validation rules, such as checking for maximum string length. They are too cumbersome to keep in the domain layer. The choice of purity over encapsulation is the second concession. Unfortunately, there are no simple solutions in software development, only trade-offs. I often see an argument that we could introduce a service in between the controller and the domain layer that would take on the responsibility of communicating with the database, and that will allow us to keep both in the encapsulation and purity. This is not the case. If that service is part of the domain layer, then we're making our domain model impure. If it's part of the application layer, then our domain model remains not encapsulated. So the introduction of such a service will not fix the issue of choosing between encapsulation and purity. The dichotomy will still be in place.